Okay, so let's continue these notes with the second part. Here we're looking at this is a solar panel. So this is how the solar panel is sitting, all right? And it's leaning against something. It is 70 centimeters away from whatever it's leaning against, and the top of it is 208 centimeters from the ground. Now, we want to determine whether this design for the solar panel is good. So I guess an assumption that we're going to make is that the best angle of inclination for the solar panel is going to be the same as the latitude. What's the latitude here? Which means 70 degrees, okay? So we need to figure out whether the angle of inclination, do you remember what inclination means? Goes up. So from the ground up, this is the angle, and we want to know if it's at 70 degrees or not, okay? Or is it close enough? Ish. Ish. Okay, so let's see what it actually turns out to be. So here I've got tan. What do you want to call this? Let's call it theta. That kind of looks like a big blob. Okay, tan theta equals, what is this opposite? This is my opposite, and this is adjacent. So what is the value for the opposite here? 208 and over 70. Okay, so now we need to figure out what the angle is. So since we're finding angle, we need to use what on our calculator? Okay, second or the shift, right? So theta equals, and you make sure you have your proper notation. You have theta equals, and then tan inverse, and write in your 208 over 70. And now punch it into your calculator, and what do you end up getting for theta? Write what on the page? You have to write this on the page. Yeah, you have to write exactly this on the page. Proper notation. Please. Okay? All right. So when we do that, we get second tan 208 divided by 70, 71.4 degrees. Is that close enough? Yeah, sure. Let's say it's close enough. 71.4 degrees is close enough. It says approximately, right? So it's within 2 degrees. So let's say that 71 degrees should be good. We should be fine. All right. So let's have a look at this last question here for our notes. What's it saying? Where's the cable? Support cable anchored to the ground. This is the ground. Hey, y'all, this is the ground. Okay, so that's the ground. Where's the cable? It's anchored to the ground from a pole. So which one of these two lines is going to be the pole? The straight one's going to be the pole, and this is going to be the what is it, cable. Okay, what angle are we trying to figure out? What angle does the nearest to the nearest degree meet with the ground? So right here, this is what we're looking for, okay? You're going to find a lot of important information on the very last sentence of word problems. So you almost want to read it backwards. Read the last sentence first so you know what you're looking for, and then read the rest of it so you can get all the information out. So let's call this, so this is angle A that we care about. So, well, let's label things now. This is going to be the opposite. This is going to be the adjacent. And this is going to be the hypotenuse. Now, if I have angle A, sorry, here I'm going to write this. Okay, tan of A is equal to what? Opposite over adjacent. Now, what can you tell me about this information that we have here? We don't have this. Don't have this number. So what are some options? So we have option 1, where we could figure out what the opposite side is, or we could be smart about it and use what we have, and we don't know how to do cos yet, but you're figuring it out, and it's use cos. Why are you using cos? Because you've got adjacent and hypotenuse. Huh. Use cos. Use cos theta. Yeah, what is cos theta? SOHCAHTOA. Adjacent over hypotenuse. Good thinking. All right. So what's the number? Cos theta equals, adjacent is 5 over 19. So actually here I could write, can I switch this theta to an A? And then my labeling is a little better. So I can do the same thing, cos inverse of 5 over 19. And then what do you get angle A as? Beauty. So here I'll just type this in so that you can see it. Cos, bracket, whoops, I don't need 2 brackets. 5 over 19, 74.7 degrees. All right. Sweet. So I haven't taught you how to do cos yet, but you already know. So you pretty much know how to do sine, cos, and tan now, even though I've just taught you how to find the angles for tan. Sine, cos, and tan all works the same. It's just the same thing over and over again. Okay? Good job. Nice work.